Hi there! In this video, I will talk about model state validation, what is it, why should we use it, and how to use it in ASP.NET Core. Also, you will see how to implement a custom validation logic that can be reused on top of validation models in our apps. So, what is a model state validation in C#? When we talk about model state, we mean model state property of the controller base abstract class from the Microsoft ASP.NET Core MVC namespace. It is of model state dictionary type, and it represents errors from two subsystems, model binding and model validation. The model binding causes errors that can occur when attempting to bind values from an HTTP request to an action method. Generally, those are data conversion errors. After the model binding comes model validation, when we check our domain's business rules. So let's explain that theory with one small example. I have a sample DTO here. For example, the model binding logic will check the proper value types are assigned to each property. That means we can't bind this JSON to our book DTO since it is going to fail because the title is not a number. On the other hand, checking that the ISBN string is a 10 or 13-digit number that conforms to particular digit calculation could be part of the model validation logic. Now, with all that cleared out, we can start implementing the model state validation. You can see this controller, and for the sake of simplicity, this action returns the OK result with the same object it has received. I'm not going to have an infrastructure layer here or work with 201 status codes for the post action. The main focus will be on the model state validation. Now, to start here, let's add more validation rules to our book class. Let's add the required attribute to make this one required. Also, for the description, I will add a max length attribute and provide the length of 25. Finally, for the ISBN property, I will assign the required attribute and the string length attribute, where I will provide the maximum length and also a minimum length with the same value. Now, let's run the app and send a request with this body. As you can see, a validation is already happening without us specifying anything except the validation attributes for the properties in our book class. That's because our controller has the API controller attribute applied, and one of its functionalities is to validate model state for us and return an automatic HTTP 400 response. I will talk more about this a bit later. For now, let's focus on the validation itself. As you can see from the response, the title property is valid and only the ISBN is invalid. Now, let's see what will happen if I set the title to an empty string and send the request again. You can see that the empty strings are not allowed with the required attribute applied. Also, if I set the title to null, I will get the same response. But if you want to allow empty strings, all you have to do is set the allow empty strings property of the required attribute to true. Now, if I add again the empty string here and send the request, you can see only the ISBN is marked with a default error message. But we don't have to work with the default validation messages. Validation attributes lets us specify the error messages we want to return for invalid input. Let's change the ISBN's error message to a more appropriate one. For that, I can use the error message property and provide the string message I want to use. Now, when I start the app and send the same request, you can see the custom message. With that done, let's focus our attention on status code of the response. We can see it is a 400 bad requests. As I said, it is an application's responsibility to check model state and act accordingly. But in our code, we don't check model state anywhere, yet we've got validation errors. That's possible because of the API controller attribute, as I already mentioned. However, sometimes we don't want to rely on automatic responses. For example, when the model is invalid, the proper status code should be 422 unprocessable entity. But with the implementation, as is, we will always get a 400 status code. So let's see how we can change that with manual model state validation. There are multiple ways of achieving the manual model state validation. Since we can access model state from our controller, the first way is to check the model state is valid property from our controller method. So let's do that. Let's add an if statement and check if the model is invalid using the ModelState.isValid property. If the model is invalid, let's return unprocessable entity and provide the model state as an argument. At this point, I expect a 422 status code in the response. Well, let's check it out. Let's send a request, but again we see 400. Again, this is because the API controller takes the validation actions into its hands and automatically returns this status code. One idea to fix this could be remove the API controller attribute. And yes, our code will work. However, we shouldn't do that, since this attribute also brings other functionalities to our controller. So we are going to fix this differently by disabling the automatic validation in our program class. Let's call the builder services.configure method and provide the API behavior options here. And then for the action delegate implementation, I will use the options parameter to call the suppress model state invalid filter property and set it to true. This will resolve our 400 status code issue. Now let's run the app and send the same request again. And as you can see, our input was validated and we received the 422 unprocessable entity status code. But we can do better here. If our controller ends up having, for example, 5 endpoints or even more, we will have some duplicated validation code. That leads us to a second way of doing the validation, using action filters. I already have the video about action filters, so I won't spend much time on how you can create one and register it. If you want to learn more about action filters, you can watch the video linked in the description below. That said, I already have a filter created. You can see the logic inside the onActionExecuting method. I check if the model is invalid, and if it is, I simply set the result of the context to the new instance of the unprocessable entity object result and provide the model state as an argument. So pretty much the same thing I did in the controller's action. Of course, I already registered this filter in the program class, and all I have to do is to apply it on top of my post action. So let's use the service filter attribute and provide the type of our validation filter. Also, I can now remove the validation logic from the action. This is also something I talk about in my Web API best practices video, so you can check that one out if you want to see what are the best practices while developing a new API project. The link, as usual, is in the description below. Now, let's run the app and send the request. And as you can see, we get the same response, but this time with much cleaner action. Now, let's see how we can add custom validation in our application. Apart from the isValid property, we can also access ModelState.addModelError method. It allows us to implement custom business logic for our model. For example, we could add a correlation check between the title and description properties. To do that, let's first implement this in our action. So, I want to check if the book's description doesn't contain the title inside it. And if that's the case, I will use the model state and call the addModelError method to add a new error message to the binding. And for that, I have to provide the key first, so I will use the name of and add the book.description property, and also add a new error message. Then again, I can check if the model state is invalid. And if it is, I will return an unprocessable entity result with the model state as an argument. Now, I can run the app and add the title for the title property in Postman, and also add additional numbers for the ISBN property. Now we have a valid object based on the validation attributes applied inside the book class. But let's send a request. And we can see our additional rule is applied. This works great, but for me it doesn't look great as I don't like adding that much validation logic inside the actions. So I can resolve this in two ways. The first way is creating a custom attribute. So I already have a class inside the custom attributes folder. This class must inherit from the validation attribute class, which is a base class for all validation attributes. Then I need a new error property of type string. It is only getter, and I will assign an error message to it. Now I need to override the isValid method. And inside, I will extract the book by casting the expression to the bookDTO type and using the validation context.object instance property. At this point, I can simply check if the book's description doesn't contain the title inside and return a new validation result with the error property as an argument. On the other hand, I will simply return validation result.success. Now, I can return to the bookDTO class, and next to the max length attribute, I will add the description book custom attribute. Finally, let's remove this logic from the action, start the app, and send the same request. And as you can see, we have the same response. At this point, it is important to understand the order of invocation here, and for that, I will place a breakpoint inside the custom filter class and also inside the action filter class. And now I will send this request one more time. And you can see that we hit the custom attribute first, and then we get inside the action filter to verify if the model is valid. Of course, since it is not valid, we get a proper response. Awesome, let's just remove these breakpoints now. The other way we can use this custom validation is to implement the logic inside the DTO class. So first, let's open the bookDTO class and hide this custom attribute. Then, our class must inherit from the iValidatable object interface. And let's implement it. Now, let's simply add some validation logic here. You can see there is not much of a logic here. Since we are inside the DTO class, I have access to all the properties I want to validate. Also, I return the error message from the description property. And that's all it takes. Again, I can run the app and send the same request, and you can see the same response. Now, with both these ways implemented, our action inside the controller looks a lot better. So, at this point, you should know how the model state validation works in .NET apps, and also how to use it with action filters or with custom attributes. So I can finish the video. Thank you for watching, and I'll see you again in the next one. Until then, all the best.